Hi, Tim Unkert here. In this video, I want to talk about big O time complexity and specifically calculus limits. Let's talk a little bit about the big O rules. So the big O rules, if I can type, are one, you take the worst case. Okay, two, you remove the constants. And three, you have different taking different terms for inputs. You take that into account. Four, you drop the non-dominant features. So specifically what I want to talk about is 4, 2, and 1 and how they relate to limits in calculus. And I'll show you that in a moment. First, though, I'm going to create a random function in JavaScript. So let me just note this is going to be JavaScript here. And I'm going to create a function. Let's call it random func. Let's take in an array for an argument. And then we'll start off. What we'll do is we'll do a nested for loop. So we'll say for let I equals 0. I is less than the array length, and I increments by 1. And then within that, we'll do another nested loop. So we'll say let j equals 0. J is less than the array length, and we increment j each time up through the loop. Okay, and what are we doing? Well, let's check if we have two of the same items. So we say if the array at index I, if that equals the array at index j, and we'll say and I does not actually equal j, well, what we'll do is we'll return true. Okay, so that's part of the function. That's one of the ways we return true. Another thing we'll return true for, so we're kind of checking, this is a random function just to illustrate my point. We're going to have one for loop here. We'll say for let k equals 0, k is less than array.length, k increments up by 1 each time through the loop. We'll say if the array at position k, if that equals the letter A for some reason, we want to know if our array has A, we will also return true. Okay, kind of random. And then we'll also create into memory. So not necessarily the most efficient function here, but we'll create the constant called Mr. Bool. And we'll say the condition if array at index 0, if that equals 1, well, then we're going to return true. And if not, we'll return false. And then we'll return Mr. Bool at the end here. Okay. All right. So let's go down here and we'll create a constant called array. And we'll say it's 2, 6, A, 4, and 5. So none of the numbers are the same, or none of the items are the same, but it does have A, so it should return true in this particular instance. So I'm just going to copy this here and go here, and let's open up the developer tools here. Let me get this up a little bit, and we'll just paste this in and run it, and we get up. We didn't call the function. Okay, so we got to do that. So I'm going to call the function. So we're going to call random func and pass in the array. Okay, so now let's redo this. Go up and copy it. Okay, let's just refresh here. I'll paste this in, and we get true. Okay, so that's good. So now if we change this, I don't know, to 2, then we should get true also. So let's just make sure our function works before I start talking about the big O. So, okay, so we'll run this, we get true again, okay? So let's try and get false. Let's start 2, 3, and we'll just call this 3. So all the numbers are different. There's no A, and the first number isn't 1. Okay, so we should get false in this case. So let's copy it, refresh, and we get false, okay, like expected. And then the last time, let's change this to 1, which we should get true for our completely random function, okay? And we'll refresh and run it, and we get true. Okay, so let's look at this function. So the nested for loop here, this is going to be O of n squared, okay? This one for loop here is going to be O of n. The reason being is that it's going to check for each item in the array. So if there are n items in the array, it's going to check n times. Here, we're going to check n times if there are n items in the array. So we get n squared. And here, we're just doing one check. Okay, so this is O of 1. We're just looking at the first item in the array. So, and let me comment that out. Excuse me. So if we added up this entire function here, we get O of n squared plus n plus 1. But really, what we're going to say is that this is just basically O of n squared. Why? Well, we're picking the worst case, which is O of n squared. That will take longer. We're removing constants, so you remove the 1 here, right? And you're dropping the non-dominant. So n here is less dominant than n squared at larger numbers, okay? Or at really any time, except if n is 1. Okay, so let's talk a little bit about calculus, why this is. Let's go to Draw Island. I haven't done anything with Draw Island in a while. I'm going to get some coffee here. Okay, so we've got our Draw Island. Now, let's say we have a limit as x approaches 0, or no, as x approaches, infinity. Let's do that. As x approaches infinity of x to the 4th over x cubed. So, excuse me. So what is this going to be? Well, this is going to be equal to infinity, right? So as x gets really large, the x to the 4th is going to win out because it's more dominant, right? The other way we can think about this is x times x times x times x over x times x times x. All right. And then we basically, and really think of this as 1 times all of this. So, right. So we cancel this out, cancel with that. We cancel these 2 out, and then we cancel this 2 out. We have x over 1. And therefore, the top is more dominant. We could also do the limit as x approaches infinity of x, let's say x cubed this time over x to the 4th, right? And this will be basically the x cubes will cancel out. This basically simplifies into 1 over x as x approaches infinity, this gets super large. So the limit is 0 because we're basically dividing by 1 by a huge number. So we're approaching 0. The limit is what we're approaching. So the bottom, the more dominant one, wins out. So let's take a look back at these rules. So we pick the worst case. The worst case is what happens, what gets larger as n approaches a really large number, like let's say 10 million or something like that. We're looking at, well, n squared, 10 million squared is going to be a lot worse than, well, 1 operation, right? Or even 10 million operations, right? We're removing the constants. Let's talk about that with limit. So let me get my eraser here, and we'll try and erase this all out. And we'll just do a limits by substitution one. So, okay, so if I say the limit here as x approaches infinity of, let's say, x cubed plus 2, well, this is going to be infinity, right? And also the limit, well, let's say if we take the other way, as we approach negative infinity, and we do x cubed plus 2, well, it's going to be a negative because it's cubed, so it's going to be negative infinity, right? The 2 doesn't matter. We're going to ignore the constant at really large numbers. Same thing with big O. So we're ignoring these constants. It really doesn't matter when you get to numbers like 10 million if you're doing 10 million and one operations. What really matters is that you're doing 10 million times 10 million, right? And this goes again with the non-dominant with limits. The 2 is obviously non-dominant. We could also we could have the limit as x approaches infinity of, like, say, x cubed plus even x squared, or x plus 1. Well, we're dropping the constant, and x is far less dominant than x cubed. We really don't have to care about this. We just care about this. And if we go to negative infinity, even if we had an x squared, which would give us a positive number, this would still approach negative infinity because the cubed is the dominant one. Anyways, I thought you might find that as an interesting way to think about big O. It really applies to these three, I think, for finding limits. If you have any feedback with this video, say, you're crazy, you don't know what you're talking about, comment in the comments below, or if you agree, or if you have another take on it, please comment in the comments below. I hope you liked this video. If you did, give it a like, as it will help get out to more people. I want to thank you for watching, and I hope to see you in the next one.